Assalamualaikum warahmatullahi wabarakatuh, and a very good morning, doctor. My name is Muhammad Fahmi bin Ahmadi with metric number CA 2010. Today I'm going to show you the result of the calculation for the assignment 3 for this subject. Okay, so my part is for the question B 1 and 2. Okay, for the question B, state as a signal CT is given as CT equal to 1 over 2 plus summation from n equal to 1 to infinity of Cn cos n pi t over 2. So the question asks us to find the coefficient of the first two harmonics of exponential Fourier series, and the question will be given an equal to n pi over 2 and bn equal to 0. So this is the calculation for the question B1. Okay, so as we have the equation given, we have to compare with the general Fourier exponent Fourier expansion, which is xt equal to n0 plus 2 summation from n1 to infinity magnitude of xn cos n omega naught t plus phase plus angle phase n. Okay, so when we compare, we got n0 equal to 1 over 2, and we got 2xn equal to cn. Okay, and we write down here, and we use the formula to get the xn right here. Xn equal to 1 over 2 square root an square plus bn square, and as xn equal to cn over 2, we just substitute here. We just substitute cn over 2. So we substitute and we plug in the value of the an that we already compare before, and we got cn equal to pi over 2 and c3 3 pi over 2, because as we calculate, we got cn equal to n pi over 2. So at the c1, it's actually have a 1 here, so it is pi over 2, and if c3, it have c3 over here and become 3 pi over 2. So we substitute the value c1 and c3 to the equation, and we got here 1 over 2 plus c1 cos n pi over 2, because it's c1, plus c3 cos 3 pi t over 2 because of the c3. Okay, after we do the mass calculation, we do the Euler relation or Euler equation to simplify our calculation. So we replace the cos part with the Euler relation, and this also part with the Euler relation, and finally we got we can simplify the answer like this. So this answer represents not also the answer for the simplify of the equation, but also give us a magnitude and the phase of our signal, which mean we have a phase number 1, phase which have a magnitude not which 1 over 2, and the first magnitude pi over 4 and pi over 4, and the 3 pi over 4, and last one 3 pi over 4. So as you can see here, there is no phase that have in the, which means there's no omega, no. So the phase will be 0. So we move on to the question number 2, which we have to sketch the magnitude and phase for the answer in question B1 that we just got. Okay, so as we already know the magnitude of all the magnitude of the signal, as we have already done in the previous question, so we just put it here: 1 over 2 pi over 4, 3 pi over 4, and 3 pi over 4, that we just got from here. Okay, so as there's no omega, this mean the phase is 0. So all the phase is 0 because there's no omega in here. Okay, so we just sketch the graph. So we have a negative 3, negative 1, 0, 1, 3 because of this. Okay, we have a negative 1, 0, 3, and negative 3. So we just do the this, and we plug accordingly. So negative 3, 3 pi over 4. Negative 3, 3 pi over 4. And so goes to the others. 0, 1 over 2. Okay, so as for the phase, we just got this the range of the n-axis, but all of the phase is 0, so we just got nothing in here because of 0. So that's all for me. Thank you.